So throughout this chapter, we've been building these truth tables. And one of the purposes of constructing truth tables is to use them to validate arguments. An argument is built around statements known as premises, and premises are like assertions that are made about something. The premises have to support the argument's conclusion. If they don't, then the argument is not a solid argument. Therefore, the argument is then rendered invalid. So we have this argument up here. If you order the special from B's Eatery, then the French fries are free. Your French fries are not free. Therefore, you did not order the special from B's. Now, often when you read some of these arguments, logically to yourself, they may seem valid or not. So again, we'll read this. If you order the special from B's Eatery, then the French fries are free. So if you did not get free French fries, then you probably didn't order the special from B's. That seems to make sense. So that seems to be a valid argument. But we're going to show whether this is a valid argument or not by building truth tables. We want to see whether it's actually valid or not. So the first thing we need to do is we need to be able to point out the simple statements and then the premises. So you can see right here, if you order the special from B's Eatery, then the French fries are free. So this almost looks like right here, if P, and I'm just going to write it in right there, then Q. So the first simple statement could be, you order the special from B's Eatery. And the second simple statement can be, your French fries are free. So then this first conditional statement right here, if you order the special from B's Eatery, then the French fries are free. That's your first premise. That's your first assertion. Here, your French fries are not free. So this looks like this is not Q. I'm just going to write it in right there. And of course, this is going to be our second assertion or our second premise. And then we have this therefore. This is our conclusion. I'm just going to put this in right here. We have a special symbol for conclusions. It's these three dots. Therefore, you did not order the special from B. So this is like not P. And that's our conclusion. So then as we write it symbolically, we write the first premise. If P, then Q. Then we put in the second premise. This one happens to be not Q. And then we separate the premises from the conclusion with this horizontal line. Then we put in the conclusion, not P. So now what I'm going to do is I'm going to go ahead and I'm going to put in these standard values, P and Q. There's only two. And then we could see that we have a not P and a not Q. So I'm going to go ahead and I'm going to put those in. Then I'm going to go ahead and I'm going to figure out the truth table for if P then Q. And of course we know for the truth table for conditional, the antecedent must be true and the consequent must be false. That happens right here. That's when the statement is false. Other than that, it's true. Now the idea is this premise and this premise must support the conclusion. So this one and, notice how I say and, this one and this one. So I'm going to build a truth table for that understanding. This and this and this. So I'm going to have if P then Q and not Q. So that's the idea for building the argument. These premises, both this premise and this premise, must support the conclusion. So we build a truth table based upon that. And of course, that truth table winds up being a conjunction. And we know that for a conjunction, this has to be true, and this has to be true for the entire thing to be true. So it's true here, and it's true here. This is where it's true. The rest are false. So now we go on the idea that if this is okay, then this should be okay. So notice how I say that. If this, then this. So we draw our conclusion by using a conditional statement. So if this, I'm going to write that out. If P then Q and not Q, therefore, and I like to say therefore, not P. So if this, then this. So we have a conditional statement here. So this, the antecedent must be true, and the consequent must be false for the entire thing to be false. So the antecedent must be true. Here it is right here. That's the only one. However, the consequent for it is also true. So there is no true false. So all the results here are true. When all the results are true, this is a tautology. A tautology means the truth values are all true. Since the truth values are all true and every one of them has to be true, then this is a valid argument. And there you go.